All right, let's get right into it. Today we're tearing down a really interesting research paper. The full title is, and bear with me, Leveraging Complex Event Processing for Monitoring and Automatically Detecting Anomalies in Ethereum-based Blockchain Networks. I know, it's a mouthful, but what it's really about could seriously change how we keep these incredibly important networks safe and sound.
So, credit where it's due. This research comes to us from a team at the University of Cadiz in Spain and the University of Malta. We're going to break down their pretty slick approach to blockchain monitoring piece by piece.
Okay, so let's frame this with a big question. We all think of blockchains as these super secure, unchangeable fortresses of trust, right? But this research poses a fascinating thought. What if the real boogeyman isn't some huge dramatic hack? What if it's actually death by 1,000 cuts? A constant, invisible stream of tiny errors that are just impossible to catch in the moment. And that idea brings us straight to the first massive challenge here, what the researchers call the blockchain's data problem. I mean, just try to picture it. A network like Ethereum is a fire hose of data. It's just constantly blasting out transactions, new blocks, logs, everything. Trying to sift through all that noise to find one tiny thing that's gone wrong. It's not just a needle in a haystack. It's a needle in a whole barn full of haystacks, and the barn is on fire. Now, you're probably thinking, well, can't we just throw some AI at it? And yeah, people have tried, but a lot of those deep learning models have a catch. They need a ton of data to learn from, which takes time. And even then, they're not always watching in true real time. What the space really needed was a new kind of watchdog, one that barks the instant something looks fishy. No training required.
And this is where the hero of our story enters the picture. It's a technology called complex event processing, or CEP for short.
So what on earth is CEP? Well, imagine a system that's built to drink from that data fire hose we talked about and actually make sense of it on the fly. It doesn't just look at one event at a time. No, it's smarter than that. It looks for connections and patterns between lots of different events as they're happening, which lets it spot really complex situations that you'd otherwise totally miss. So here's how it actually works, and it's kind of beautiful in its simplicity. First, you have a simple event, right? Let's say a new block gets mined. That's step one. Immediately, and I mean instantly, the CEP engine checks that event against a bunch of rules you've already set up. Like one rule might be, A, is the number of this new block the same as the last one? And if the answer is yes, if that rule is broken, bam, step three. A complex event, your anomaly alert is triggered right then and there.
Okay, so that's the core technology, but how do you actually wrap a whole system around it? Well, the researchers designed a really clever architecture to make this all happen.
So this diagram gives you the bird's eye view of their setup. You can see the data flowing from the blockchain on the left. It gets funneled into this thing called a message broker. You can think of that as kind of like a traffic cop for data, which then sends everything over to the CEP engine, the brains of the operation. And the really smart part? The whole thing is containerized, which just means it's super portable and easy to set up on pretty much any network you want. So, the system is built. Now for the really fun part. It's time to unleash this thing on live, breathing blockchain networks and see what it can actually find.
The researchers turned their CEP engine into a kind of digital bloodhound, training it to sniff out 5 very specific types of weirdness. And these are all things that, just shouldn't be happening on a healthy network. Getting 2 blocks with the same number? That's a huge red flag. Block number skipping? That's not right either. And mining times that are either way too fast or way too slow can be a sign of major trouble.
And they didn't just let this thing run for a weekend. They set it loose on the Ethereum mainnet for 106 straight days. This graph here with all these crazy spikes, well, that gives you a visual of just how many of these little anomalies it was catching every single day.
Now, let's look at the actual numbers, because this is where your jaw might just hit the floor. On Ethereum, over those 106 days, it caught over 45,000 instances of blocks being mined too quickly. But check out the Polygon test. In just 1 week, 7 days, it found over 170,000 cases of identical block numbers. This isn't a theoretical problem, folks. This is real stuff happening at a mind-boggling scale.
So after all that, what's the big takeaway? Why does this research actually matter for the future of blockchain?
Well, the contributions here are pretty huge. The team created a brand new way to combine CEP and blockchain. They built it into a system anyone can set up, and they proved it can watch these networks in true real time. This is a big deal. It basically moves us from being detectives trying to figure out what went wrong yesterday to having a security guard on patrol 24/7, catching problems the moment they start. And look, you don't have to take my word for it. I think this quote from the paper itself just sums it up perfectly. The system works, it can automatically find these anomalies on different blockchains, and it opens the door for off-chain tools to finally get real-time intelligence about what's happening on-chain.
And that really leaves us with a powerful final question to chew on. Blockchain's whole reason for being is trust. And if we can now watch these networks with this incredible level of detail in real time, it makes you wonder, right? What new kinds of applications, what higher levels of security and trust can we start building now that this is possible?
And that's our look at this really fascinating piece of work. Just one more time. The paper is Leveraging Complex Event Processing for Monitoring and Automatically Detecting Anomalies in Ethereum-based Blockchain Networks. You can find it with the DOI you see on your screen. Thanks for diving into this with me.